Hello and welcome to Sociology 324, the only class at Albion College that now knows how to calculate a standard deviation. I hope. Do I look different today? I'm not sure if I personally look different today, but I last night replaced the light fixture right above me in the panic room. So hopefully I'm getting some good light, on me, and everything is looking good. Purpose of today's video is to review the homework. So getting into that, you were given a three-part homework here: descriptive statistics, summary statistics, and then both of those things in stata. So part one, you were asked to pretend that you are a researcher for a coffee company, and here is a univariate frequency table that tells you the number of coffee drinks in the last week, or number of coffee drinks in the past week, and it's controlling for gender, right? So we have one column here for women and one column here for men. You were asked to create a frequency table that included the relative frequencies and the cumulative frequencies. And so when I did this is what I came up with. What I have here is, in my very first column, I have the total number of drinks, 0 to 8 plus. So this is mostly an interval variable, but that 8 plus introduces a little bit of ordinal stuff. But it's not a very big column. We can generally treat this as an interval variable. And to calculate the relative percentages, what I did was create 2 columns for women, relative and cumulative, and 2 columns for men, relative and cumulative. And to get these relative frequencies, right, the percentage of women and the percentage of men that falls into each category, I had to take the F and divide it by N and make sure I was doing that in a consistent fashion for women and for men. That's the only way to make comparisons. The big thing that's being tested here is it appropriate to make comparisons between these two groups based on the information that was given to you on the first page of the homework? The answer is no, it's absolutely not, because the ends are so different. We have almost twice as many men in this sample than women. So what I want to do is direct your attention specifically to the category number 3. So that is 3 coffee drinks in the last week. 170 women fall into that category. 170 women had 3 coffee drinks last week, and 259 men had 3 coffee drinks last week. Therefore, a higher number of men had 3 coffee drinks than women. But look at the relative frequencies. 20, even though that's a smaller number, 170 is definitely smaller than 259. Well, 21.52% of women fall into that category, whereas only 16.23% of men fall into that category. So even though the raw number is larger for men, women are relatively more likely to have 3 coffee drinks in the last week. Yeah, so to get this, I took F for each gender, and I divided it by N. For women, that was 790. For men, that was 1,596. And I got a table that looks exactly like this. 14.3, 6.33, 11.65, 21.52, 20.13, 10.76, 6.48, 6.08, 2.78%, which cumulatively will sum to 100%. So you could have used any category in here, right? 0, 1, 2, 3, 4. You could have used any of these to make your comparisons. But what I was looking for is that you cite exact numbers, you draw them directly out of the table, and I was looking to make sure you only compare within the same category. So put another way, I don't want you comparing the number of women, or the percentage of women consuming 0 coffee drinks to the percentage of men consuming 2 coffee drinks. By joining those categories, we have led to no conclusion whatsoever. So we want to stay within the category, cite exact numbers, and compare relative frequencies rather than raw frequencies to one another. So here are the 2 that I came up with, and these don't have to be the 2 that you came up with, but this is what I had. Men are more likely than women to consume no coffee at 27.01% compared to 14.3%. There we go. I stayed within the category of no coffee, and I cited the exact rates. My second finding was women are more likely than men to consume 3 coffee drinks per week at 21.52% compared to 16.23%. So that was, I actually kind of gave that earlier, but nevertheless, those are good, clean interpretations from this table. And then question number 3 in part 2 asked you to use the cumulative percentage column. So that is what happens when we stack our columns, and the percentage in the cumulative cell refers to the total percentage of people that fall into that cell's category and less than, right? So 3 or less, 5 or less. And here's what I have. Men are more likely than women to consume 3 or fewer coffee drinks per week at 83.09% compared to 53.79%. Also, women are less likely than men to consume 6 or fewer coffee drinks per week at 91.14% compared to 96.5%. Stay within my category, cite the exact rates. As long as you did that, you should receive full credit. I mean, assuming that you wrote this in a way that I understand what you're doing, it should really receive full credit. So that part wasn't too difficult, but it does require some care. There's a lot of little calculations that you got to make sure that you do well and you do accurately. Okay. Getting to what was, I think, a little more challenging, central tendency and dispersion. You have been given data from a sample. I circled that because that's going to become important in just a bit of time. Of 14 Michigan adults, which indicates the number of times in which they ate at a fast food restaurant in the last week. Data are as follows, and then you're given a non-ordered data set, which I hope you put in order to get some of the later stuff. So calculate the mean, median, mode, range, and standard deviation of the number of times per week. Can we calculate all of these? Absolutely, because this is an interval variable. You will remember, you can only calculate a mathematically appropriate mean for a variable that is measured intervally. And therefore, we can only calculate standard deviation if we have a mean to start with. The mean is so crucial to the creation of the standard deviation. So I'll get to the standard deviation later. Let me just move down here to my answers. So here's what I got. Let's actually start with the mode. The mode here was 0. The mode is the most common. And so I didn't write the full sentences here, but I will speak them to you like how I would have worded this because you were asked to express everything in a full sentence. The mode is 0. Therefore, the most common response in this data set, in this sample, is 0 times eating out last week, right? Most common. Or you could have said the modal response, and that would be putting it in a sentence as well. What we see here, do you see this? You follow my cursor. If you see this little thing, X with a tilde over it, X tilde is... that's the sign for median. I don't use that very often because the median does not show up in other more complicated equations. So just know that the median here, that is the median. The median is 1.5. Therefore, how would I interpret that? Well, the median is a midpoint. So I would write the midpoint value of this sample is 1.5 times eating out last week. And then the mean, X bar. I used X bar. Why? Because I looked up here and said that it was a sample. So I knew I didn't have to use mu. I knew I should use X bar. So I got this by doing the summation of X over N. the summation of x is 34. It is each value added to each other, right? So if I look at my table here, 0, 0 plus 0 plus 0 plus 0 plus 1 plus 1 plus 1, so on and so forth, get to the 14th data point. That gets to 34. I then divided that by 14, and I have a mean of 2.43. Or, put another way, the average number of times eating out last week in this sample is 2.43. And our range, not too difficult. We just take the largest number and subtract from it the smallest number. 9 minus 0 equals 9. The range of this distribution is 9 times eating out last week. Okay, getting to the meat of this, though. Variance and standard deviation. Notice how in the word problem, like you weren't asked specifically to calculate variance, but what you should have realized is you can't calculate standard deviation if you don't calculate variance. Variance is a step in the SD, the standard deviation process. So I created a table here very similar to what you got in lab last week when we did an example on age at first childbirth. So you're given the raw data points. You have to be given something, right, in order to get started. And I created a column here for xi minus x bar. That is what we call deviation from the mean. So xi minus x bar, that's each observation of x minus the mean of the sample. The mean of the sample is 2.43. So I subtracted from xi 2.43 and got the following that you see in this column. That sums up to negative 0.02. The reason why that sums really closely to 0. The reason why that doesn't sum is because of some rounding issues. Issues is not even really the right way to think about it, but you rounded the mean and you rounded each deviation from the mean to 2 decimal points. Therefore, it's appropriate to also round this to 2 decimal points. And so now looking at that negative 0.02, what you're introducing there is what we think of as rounding error. And I can take that's really close to 0, and it that would round to 0.00. So we're going to look at that and say that is good, and we're going to go forward. Because that sums essentially to 0, I need to find a way to get aggregate deviation, which means I have to get rid of my negatives, which means I am going to square each deviation from the mean. So moving on from xi minus x bar, I simply take the value in that column and square it. And finally, at the bottom, you see what's highlighted here in red. That is my sum of squared deviation. 97.4286. That goes in the numerator of my standard deviation formula. Notice what I've written here is the formula S, that's sample standard deviation, equals the square root of the summation of xi minus x bar squared over n minus 1. Why n minus 1? It's a sample. I had to correct for the sample estimate. So n minus 1, 14 minus 1 equals 13. So what I have here is the square root of 97.4286 over 13. And that reduces to the square root of 7.4945, which is, right, that number, 7.4945, that number is the sample variance. That number is expressed in squared units. In order to take away that squared property, I must take the square root now. By doing that, I get my answer of 2.74. The standard deviation is 2.74. So how would I interpret these things? Well, the average number of times eaten out last week is 2.43 with a standard deviation from the mean of 2.74. That standard deviation indicates that the average distance from that mean of 2.43 is 2.74 times eating out last week. That's my answer. Hopefully this is we've now done this. This would be your third time going through this, right? Once being guided through and guided in class, once doing it on your own in lab, and now on a homework assignment. Don't forget these skills, might come in handy. And finally, we get to Stata. So I asked you to show me that you can calculate descriptive statistics and create them. So you were to make a pie chart, a bar graph, and a histogram. There wasn't a requirement anymore of like you have to use one of each level of measurement. I just want the graph to both look good and be appropriate. So to do this, like the way I think this works out best, I'll give you feedback if I think your stuff looks unprofessional. I'll give you some help on making it better. But a pie chart, like I just think that works best with a nominal variable. We don't want too many categories. The bar graph calculates means over some other category. So you could have done something like number of children by level of education, age at first marriage by level of education. I don't know. Like it's just, but you want a category for which you can calculate a submean. And then the histogram, I think that works best with interval variables. Although you can make it for ordinal variables, you would just, for that one, you would absolutely want to stay away from nominal variables because you can't put nominal variables in any type of consistent ordering. So I'm excited to see what everybody came up with. Hope we are enjoying our morning off and away from class. You'll get your grades shortly for the homework assignment. And we are going to go into confidence interval. We're going to learn about standard errors and confidence intervals on Thursday when we meet in class. I'm excited. And I'm really happy with where this class is right now. Okay. If you feel yourself struggling, don't hesitate to reach out and to let me know. And I'm happy to work with you to try to answer questions that'll help you feel more confident. Thanks, and have a great rest of your day. Take care.